we are here again to discuss some application part of differentiation. In the last lecture that you must have gone through, Subbu sir has explained how we can interpret the differentiation as a geometrical meaning of it and also some application of the differentiation. Now here we will going to discuss how we can apply those concepts of differentiation in applying those concepts by calculating some important function of physics like velocity, acceleration and some other functions also. So let us start from the point where we have ended in the last lecture. You must have solved a problem that we have given you earlier to calculate the differentiation of a function that is x to the power 3 and we have to differentiate it with respect to x. So in the last lecture we have also given you a formula that if you calculate the differentiation of x to the power n, then the result is n into x to the power n minus 1. And you have seen the derivation part also and the geometrical meaning part also. But here I am going to simply apply this formula to calculate the differentiation of x to the power 3. So here the differentiation you will get is simply 3 into x square.
We can also here apply the derivation of
part of the
formula.
Differentiation of x to the power 3, how we have achieved at this part. So let us see, let us define a very small number h, and it is so small that we can say that this number is very close to becoming 0. So the differentiation will be x plus h whole cube minus x cube divided by h. This is how we have discussed the application of x to the power 2 differentiation. Now here if you expand this term we can get that limit h tend to 0 and this is simply a plus b whole cube. So we can write this as a cube plus b cube plus 3a square b plus 3a into b square minus x cube divided by h. Now in this equation x cube can be easily cancelled out and limit h tends to 0, h will also cancel out. So the function remain here is h square plus 3x square plus 3x into h. Now in the last line we can simply apply the value of h tend to 0, that is very close to 0. So these two terms can become 0 and the final result will be 3x square, which is same as this result. So either you can apply this derivation or you can simply use this formula and you will get the same result here. Now this is how we have discussed to calculate the differentiation of a function. Now in this lecture I am going to be focused more on the application of such differentiation in various parts of physics. So let us start with some very basic or fundamental concept of physics. Even a student of 8th class, 9th class, 10th class, they know that velocity is displacement upon time. So what is the difference between the definition of velocity in 10th class or in 11th class? So in the 11th class we get to calculate two type of velocities. One is called instantaneous velocity and one is called average velocity. Instantaneous means rate of change of displacement at a given instance. So let us say if we represent s as the displacement of a given particle.
These are the conventions, like we take s as a displacement.
We can take s or r also, it is up to us, but we are saying that this function s here represents the displacement of a particle in a given plane. So if we calculate the value of displacement as a function of time, so at any given time t, let us say, the displacement is equal to s is equal to 2t square plus 3t minus 5. Let us say this is a general value of displacement at any given point of time. So what is the value of velocity at that time? So the velocity is simply rate of change of displacement at a given time, and rate of change means we can write this equation as v ds by dt. Now, as you have already learned how to apply ds by dt for a given function of x to the power n. So here the same thing is given in terms of time. So here,
I think can we relate average velocity and instantaneous velocity by some expression?
that we will discuss through graph.
Through graph.
So I am going to come to the graph part also. In the graph part, we will relate what is the difference between average velocity and instantaneous velocity, and how average velocity becomes instantaneous velocity through some extrapolation. So here, if you differentiate this function ds by dt, so here since 2 is a constant number, so 2 will not change. Differentiation of t square according to the formula is simply 2 into t, because it is x to the power n, so that t to the power 2, so n is 2, so 2 into t is the differentiation of first. And for the second function, 3 into differentiation of t is simply 1. So this is the final value of velocity at time t. Now if you want to calculate this velocity at some time, let us say t is equal to 1 second. So simply put this value in the equation, and what we will get is velocity at this time will be simply 4 into 1 plus 3, that is 7 meter per second. So you see, it is very simple to calculate velocity once you learn how to apply the formula of differentiation. This is how important concept of differentiation while learning some basic and fundamental concept of physics is. This is not everything that we have learned about differentiation. There are various applications of differentiation, like a similar way in which we have discussed the instantaneous velocity. We can also calculate some very other important function of physics, like you must have learned about the acceleration. What is acceleration? Acceleration, as we have learned in 8th, 9th, 10th class, is simply change in velocity upon time interval. Here, when we come to 11th class and when we apply the differential equation, so acceleration is defined in two ways. One is called average acceleration and one is called instantaneous acceleration. Average means for a given time interval, instantaneous means at a given time. So instantaneous of any value can be calculated at rate of change at that point of time, that is A is equal to dv upon dt. So you can see these two are very similar type of equation. The only difference is here it is displacement, here it is velocity. So once the equation of velocity is given, you can always calculate the value of acceleration in the similar
can we
fashion.
understand the definition of velocity as rate of change of displacement?
Yeah.
And after getting velocity, acceleration is rate of change of velocity.
That is instantaneous one.
That is instantaneous.
And the average one is difference of velocity over time interval upon time interval, and these two can be related also. We can see that also. And similarly, in 9th class you must have learned the definition of force using Newton's second law. What is Newton's second law? It simply says that force is change in momentum upon time interval. So again, F can also be defined in two different ways. One is the average force and one is the instantaneous force. The average force is difference in momentum over a finite time interval upon time interval, while the instantaneous value of force is simply F can be written as dp by dt, and this is rate of change of momentum at a given time interval.
Can we explain this like here, that S which is written here is actually displacement?
Yes.
And if we talk about V, it is actually velocity.
Yes.
And if we talk about acceleration, this is denoted by A, and finally this F is being
Force here.
force here, okay? And force is also a vector quantity, it has a direction. And finally momentum is denoted by P.
And
So
this-
these are the terms which we have used,
Yeah.
and these are the
very common term that we must have encountered while studying some basic concept of physics, like chapter of motion and chapter of force, when you discuss this thing in 9th class, from 9th class onwards. So now we have discussed about two type of quantities, like average value of the quantity and the instantaneous value of quantity. So what are the relation between the two quantity? Let us discuss this using a graph here. Let us say this is displacement and this is time interval. Now if any general graph of displacement with time is given, so if there are 2 points, let us say 1 and 2, if we join these 2 points, the difference in the position of these 2 points will give us, let us say this is time t2, this is time t1, this is position s1 and this is position s2. So average velocity is what? Average velocity is displacement over this finite interval upon the time interval. So the displacement, or we can write it delta s here, that is change in the position, delta s, that is simply s2 minus s1, and this is a vector quantity, so we have to add arrow over the quantity also. Now the time interval delta t, it is simply t2 minus t1 here. So average velocity, when we talk of average velocity, the average value of the velocity is simply change in position, that is del s2 minus s1 minus t2 upon t2 minus t1 here. Now when we want to calculate the instantaneous velocity, that is velocity at a given instance, then you must have learned in the last lecture that Subbu sir has explained how a chord become a tangent. It is exactly the same thing here. When we try to bring this point 2 very close to 1, so when this 2 and 1 are so close that the distance between them can be said to be very close to 0, at that point the line connecting point 1 and point 2 is similar to like a tangent passing through this point 1. And this angle, let us say if it is theta, then the slope of this line, the slope of this tangent here, this slope can be written as tan theta, and from last lecture we can remember that the tan theta is simply in this graph ds by dt. So this ds by dt is said to be instantaneous, or the value at point 1, while this quantity was the average value between point 1 and 2. So in the similar fashion, we can also relate the average.
I try to understand this physically, like at 11 am a car has started moving.
Yeah.
And till 12 pm we have seen that what is the distance
traveled.
So in between its velocity may have come up, sometimes it may have stopped
Also.
So we are excluding all such situations, and we are taking the total distance or displacement traveled upon 1 hour that has taken. That is the average velocity.
But and if at any instant, let us say at a red light, and we have stopped the car, so at the red light the velocity was 0. So that velocity is instantaneous velocity, let us say 1130 hour.
Okay.
And if we start the car again and on a smooth road, let us say we are moving at 60 km per hour. So that's 60 km at any time, let us say 11:45 am. The velocity at 11:45 am is called instantaneous velocity at that time, that is 60 km per hour. So between 11 to 12, there may be different type value of velocity at different times, but when we calculate the average, we are only concerned about the total displacement and total time taken, that is 1 hour here. And if the total displacement is 30 km, then the average velocity is 30 km per hour. The instantaneous may be 0 or 60 or 10 or 15. It can be any value, that is the value at a given instance between the interval of 1 hour.
So basically your vehicle shows you, either it is a car or a bike, that what is the instantaneous velocity.
Yes, the speedometer reading is always about the velocity at that point of time, that is called instantaneous velocity, and average is simply over an interval of time. So in the similar fashion, we can also discuss acceleration, that is rate of change of velocity, average and the instantaneous velocity, force, that is